This is chapter 10, section 1, and it's on early ideas about evolution. And the key idea here is that there were theories of biological and geologic change before Darwin came around. Okay, so early scientists proposed ideas about evolution. And evolution, your textbook defines it as the biological change process by which descendants come to differ from their ancestors. So in other words, you can kind of shorten that by saying change over time. But more specifically, it's how do the descendants differ from their ancestors? And it's a biological change. So there's differences, slight differences in biology that influence how descendants will come to differ from their ancestors. And we're going to talk more in the rest of these videos and the rest of this chapter on how exactly evolution happens. How do the descendants come to differ from their ancestors? And a species can be defined as a group of organisms that reproduce and have fertile offspring. So if you hear about all these different species of birds, and or even you think of maybe something not as small in difference as like birds, but something like a bird from a monkey or something. And the main definition that we use for species is can that group of organisms reproduce with each other, and when they reproduce, can the offspring they have, can they be fertile? Meaning, can those offspring themselves have other offspring? So Darwin is kind of the guy who gets most of the credit when it comes to the theory of evolution, but there are three other, and even more, other people who kind of helped to lay down the groundwork that helped to influence Darwin. And together, all these people can be known as with what is termed naturalists. So a naturalist was just someone who, because back in especially the before really the 20th century, the prevailing view in science was just you could kind of explain a lot of things by because God, so like what caused all these differences in species. It was just solely that one species arose just because that's just how God created that species. There wasn't any sort of prior ancestor of that species. That species was just there, and it didn't change so much. It kind of was what it was. Whereas these people called the naturalists kind of came about, and they tried to they weren't so much atheists, meaning they didn't believe in God. They were more so saying, although some possibly could have been, but a naturalist is simply someone who is just like, rather than just kind of just saying, oh well, God did it and end of discussion, they tried to look at things and say, hey, can we find some sort of natural cause for all these variety of species that we see in our world? And so the first one that's listed here is Carl Linnaeus, and he is famous for his classification system, where he went all the way from kingdom, the most broad category that we put organisms into, all the way down to a species that we defined earlier. And so that kind of helped to give the idea of how do we, what kind of boxes, so to speak, can we put organisms into? How can we kind of organize this biological world? Because, scientists were discovering all different kinds of organisms, and it was sort of like, how do we organize all this? Then you had Buffon, who kind of brought up, again, what I mentioned earlier, the idea that species have a shared ancestor rather than one species just randomly arising, the other species just randomly arising, and they're not being related to each other. It's just simply, oh, God made this species of bird, and then He made this species of bird. There was no inherent ancestor of those two birds, those two species of birds. And then Darwin, Darwin did many things, but kind of I guess if you put it into a one sentence definition, he came down to finding that more complex forms developed from less complex forms. Just so the idea that you had a change over time, that this idea called natural selection that we'll talk about later, where nature, a certain environment, would select for certain traits that were better suited to that environment. And related to that idea was Lamarck, who said that environmental change leads to use or disuse of a structure. So the best way I've always remembered Lamarck is the analogy of a giraffe. Lamarck was someone who thought that if a certain organism used a certain part of their body, they could pass on those traits to their offspring. So meaning he pictured like a something like a giraffe, with a shorter neck though. And so as they kept trying to reach for the taller plant, they eventually couldn't reach the plant. And so, but some little baby giraffes had necks that were slightly longer than others. And so over time, by them stretching their neck to reach for the leaves, they could kind of eventually stretch out that neck and then pass on that trait to their offspring, and then their offspring would keep stretching out the neck. And it is basically the idea that you can whatever traits you acquire in your lifetime, you can pass them on to your offspring, kind of like a bank account or something. Another example would be like if you're a bodybuilder, you go lift a lot of weights. If you have kids, then your children will be stronger than some other adult who didn't lift weights. And we now know, just from modern day genetics, that isn't true. Just because one adult lifts a ton of weights has no influence on whether or not their kid's going to be any stronger than an adult who doesn't lift weights. But still Lamarck had was a leading voice at the time who tried to put forth this idea that just trying to think about how species can change over time. And then another big influence on Darwin's theory was the idea of geologic change. So around the time of Darwin, late 1700s and everything, there was this idea that the Earth was really only a few thousand years old. And Darwin and some geologists at the time started to see things like fossils, started to spend a lot more time studying the Earth, and they discovered certain things that made the Earth seem like it was possibly older than it might have been. And so the different theories of how geologic change can happen that helped to influence Darwin are the first one's catastrophism, which is that natural disasters such as your floods and volcanic eruptions have shaped landforms and caused species to become extinct. So something like a volcanic eruption is going to, if you have a volcano that erupts and you have all these species out here, these organisms that, that could very well kill off these organisms and then change this landform, or you could have some drastic flood that could wipe out species and alter the landscape. Then there's something called gradualism. And so it's a theory that says that there's changes in landforms that come about from slow changes over a long period of time. So kind of like a river that flows through a canyon where, slowly but surely that river is going to erode away the rocks in that canyon to where, maybe this was all filled in at one point, but slowly but surely that river, almost like a sawing a piece of wood, just little by little over time until you had it saw all the way through this canyon. And then the most prevalent view is going to be uniformitarianism, and that's that the geologic processes that shaped Earth are going to be uniform throughout time, meaning that the same processes that are going to influence the Earth now in our present time were the same ones that were operating, thousands, hundreds of thousands of years ago. So all three of these theories have a role in geologic change. There isn't so much that catastrophism is inherently wrong, but uniformitarianism is going to be the best explanation for a lot of the geologic features that we see. And so it's known as the most prevailing theory of geologic change, where so every layer of rock that you see in this sample here was formed by the uniform, meaning consistent, laying down of sediment that's still going to occur today. So all the way up top here, you're going to continue to have this laying down of sediment that's going to occur. And the idea is that that process is going to occur at the same rate of time, unless you have some sort of catastrophe or something that dramatically alters that, and changes that process. But other than these rare dramatic catastrophes, the laying down and the changing of Earth happens almost like clockwork. It's very consistent. It doesn't speed up at different times or another. All right, that's going to do it for this section.